Hi everybody, I'm Mike Poland, the scientist in charge of the Yellowstone Volcano Observatory, and this is the monthly update for October 1st of 2022. We're going to start this update out with the third in our three-part series on the different types of thermal features in Yellowstone. Back in August, we talked about travertine features, which we find in the Mammoth Hot Springs area. Last month, we talked about neutral chloride features, things like Old Faithful and Grand Prismatic Spring. And this month, we're coming to you from Artist Paintpots, talk about the third type of feature, acid sulfate springs. Now these features start as snowmelt and rainwater percolate deep into the earth. They get heated by the magma chamber that's cooling well beneath the surface, and then that water starts to rise. It picks up gases that are emitted by that cooling magma body as well. Now, as the water starts to get close to the surface, it might begin to boil. Now, the water itself will go off and form one of these neutral chloride features like Grand Prismatic Spring or Old Faithful. But the gas, as it boils, can separate, and that gas is a bit acidic because of the carbon dioxide in it. Now, as that gas rises separately to the surface, it starts to dissolve some of the rock because it has that slightly acidic pH. And as it dissolves that rock, it turns it into this white kind of chalky clay. And as it mixes with little bits of water that's at the surface or just beneath the surface, we get paint pots just like this. So these sorts of features are mostly driven by gases that come off of that water that's been all the way down to the magma chamber and risen all the way back to the surface. All right, now let's talk about the seismic, deformation, and geyser activity that's happened during the month of September.
During the month of September, earthquake activity was slightly elevated in the Yellowstone region. Now, typically we see about 150 to 200 earthquakes per month. But in September, the University of Utah seismograph stations, and they're responsible for the operation and analysis of the Yellowstone seismic network, they located 678 earthquakes in the region. This may sound like a lot, but it's actually not even the most earthquakes we've come close to in a given month. A few years ago, we had more than 1,000 earthquakes a month happening in Yellowstone, and even just last year in 2021, there were months with over 800 earthquakes. Now, 510 of those 678 earthquakes occurred right here in the area between Norris Geyser Basin and Mammoth Hot Springs. This is the Grizzly Lake swarm of earthquakes that's been going on since late July, and the largest earthquake of the month, a magnitude 3.9 on the morning of September 18th, occurred as part of this swarm. Now, this belt of seismicity from Hebgen Lake into the north-central part of Yellowstone National Park is by far the most seismically active part of the region. In fact, in 2017, there was a 3-month-long swarm that occurred just to the west of the current swarm. That was the Maple Creek earthquake swarm. That had 2,400 located earthquakes over that 3-month period, the largest of which was a magnitude 4.4. Just to put this swarm here in context, we've had about 800 or so earthquakes in this particular Grizzly Lake swarm since it began in July, and it's continuing into August. So this is one of these long-lived swarms in Yellowstone. That's a result, really, of water interacting with pre-existing faults, which really are present all through the area. There were a few other swarms in the region during the month. For example, this small one here just in the lake area, this one here north of the Old Faithful area, and then this one on the south side of Lewis Lake. All those swarms had about a dozen events or so each. So slightly elevated month for seismicity, but nothing unprecedented, mostly due to this swarm of earthquakes occurring near Grizzly Lake. In terms of ground deformation, we're seeing the seasonal trend that we expected to see that has just taken place in the month of September. Now, this is vertical deformation at the White Lake GPS station on the east side of the caldera in the Sour Creek Resurgent Dome. Plot spans the last 2 years, and each one of these blue dots is 1 day of data. Downward trends indicate subsidence, and upward trends indicate uplift. Now, the overall trend, even stretching all the way back to 2015, is of subsidence of about 2 to 3 centimeters, or about 1 inch every year. But that's interrupted in summer months by a pause in the subsidence or even a slight amount of uplift. You can see it here in the summer of 2021, and again here in the summer of 2022. Now, that's caused by groundwater. That's water that's mostly percolating from snowmelt, gets into the surface slowly, the subsurface slowly, and it causes the ground to sort of puff up like a sponge. So every summer, as that snowmelt percolates into the subsurface, we get a little bit of uplift, or at least a pause in the subsidence, but then it turns around by late summer or early fall. And that transition began here in the May-June timeframe, where we saw a little bit of uplift, and then right here in mid to late September is when we saw the transition back to subsidence. The exact same story is what we see over on the other side of the caldera. This is the Old Faithful GPS site near the Mallard Lake Resurgent Dome. Overall subsidence interrupted in the summertime by these trends of a slight amount of uplift, but you can see the same transition from that slight amount of uplift back to the subsidence that's been ongoing since 2015 occurred right here in mid-September near the Old Faithful site. Also at Norris, the same story remains true. Norris hasn't seen as much subsidence as the caldera, really not a whole lot of change here in 2021. A little bit of uplift during the summer of 2021, then back to subsidence. This deviation right here at the end of 2021 is due to a winter storm that buried the antenna in snow and ice. A little bit of uplift here again in 2022 summer, and then the transition is occurring now in mid-September to go back to that subsidence trend. So we're not seeing a whole lot of new deformation in the Yellowstone area, really just looking back at those normal trends of subsidence in the caldera, not much deformation at Norris, and the seasonal signal, which is transitioning back to subsidence now that we're entering the fall season. And finally, looking at the tallest geyser in the world, Steamboat Geyser in the Norris Geyser Basin. This is the temperature measured in the outflow channel from Steamboat. All of this variability you see in the high temperatures in the early part of the month are due to minor eruptive activity. That's when the water is splashing a few tens of feet maybe above the geyser pretty constantly. Not a major eruption, but it sort of goes along, and then September 18th, that's when we have a major eruption with the geysering that can go up hundreds of feet. And after that, you can see the temperature drops quite a bit, and then we go into these daily variations. This is when the outflow channel is essentially dry. There's no more minor activity, and we're just seeing daily temperature variations here. So typically we see some minor activity that leads up to a major, like you can see here in the early part of the month. We're not seeing any of that minor activity now, and that suggests that there isn't a major eruption of Steamboat that is imminent. Hopefully, though, we'll start to see some minor activity in October and maybe leading up to another major this year. This is the 9th major eruption of 2022, and this is well behind the pace that was set in 2018, 2019, 2020, and 2021. So it seems that the geyser may be waning and perhaps is heading back into slumber, but hopefully it's not done just quite yet.
Well, that does it for the October update. Now remember, if you have any questions, you can email us anytime at yvowebteam, all one word, at usgs.gov. Until next month, stay safe and stay healthy. We'll see you later. Bye-bye.